Did you forgot?
Yes, sir.
Electromagnetic waves are transverse waves. Transverse waves that consist of the electric field and the magnetic field. And the two waves, the magnetic field wave and the electric field wave, moves at 90 degrees to each other. And what is the speed of the electromagnetic wave?
It's 3 times 10 to the power of 8.
Okay, perfect. And which electromagnetic wave is more dangerous?
A gamma ray, sir.
Okay, perfect. Perfect. Okay. Have you guys done electrostatic?
No, sir.
Okay. I just want to do 2 questions, electrostatics and electricity. Okay. Okay. Let me check it out. Okay. Sleep. Okay, before we continue, what happens if we have 2 charged spheres, ne? With 2 different charges? What happens to their charges after we have brought the 2 spheres together and separate them? Misa, what happens? If you bring 2 spheres or together that have different charges, if you bring them together and then separate them, what happens to the charges? You forgot.
Yes, sir.
Okay. So what happens is the electrons will flow from the object which has excess electrons. The object which has a lot of electrons will lose electrons. It will lose electrons. Where there is a lot of electrons, the electrons will migrate to a place where there is less electrons. And until the 2 spheres have the same charge, meaning that the potential difference will be 0. And that means there will be no more electrons moving from one sphere to another. Because why are you moving to another sphere when both spheres have the same charge? It means there won't be any need. You understand?
Yes, sir.
Yes, so that is the nature of electrostatic questions that you're gonna get in your exam. So, do you know the formula? Can you define the term charge quantization? Charge quantization.
All charges are multiples of the smallest charge.
That is true. And what is the magnitude of that smallest charge?
It's 1,6 times 10 to the power of 9 minus 19.
That is perfect. That is perfect. Okay, can you see what is on the screen?
Yes, sir.
Okay, question number 1. Which sphere has an excess of electrons? Which sphere has an excess of electrons? Which one has a lot of electrons?
Sphere B.
Okay, sphere B. That's true. The two spheres are allowed to touch. Will the electrons be transferred from A to B or from B to A? Which one?
I think it's A to B.
It's from A to B, but you have told me that, let's say, when there's a lot of water on the other side of an aperture or on the other side of the dam, it means the water will move from where there's a lot of water to where there isn't a lot of water. Am I making sense?
Yes, sir.
So the same thing with electrons. The electrons will move from where there's a lot of them, which is from
To A.
B to A. You understand?
Yes, sir.
Yes. Now, the spheres are now separated. Calculate the new charge on the sphere B. How do we calculate the new charge? The formula is, or how do we go about it?
Q new is equals to Q1 plus Q2 divided by 2.
Q1 plus Q2 divided by 2. Which is Q1 is 3 by 10 to the power of minus 6 plus minus 2 times 10 to the power of minus 6. All divided by 2. And what will be the answer? What will be the answer? It will be, I think, 0.5, right? The unit is coulombs. Is it true?
Yeah, let me check, sir.
Okay. It's true, ne?
Yes, sir.
Okay, perfect. Calculate the number of electrons transferred during the contact. Okay, what is it that we have calculated? They said calculate the new charge on sphere B. The new charge will be 0.5 times 10 to the power of minus 6. That's perfect. Okay. 6.4. Calculate the number of electrons transferred during the contact. Formulas.
I think we're gonna use the change of Q is equals to Q final minus Q initial.
I like how you know all these things by head. You make it very, very easy, look very easy. Okay. Q final is what?
0.5 times 10 to the power of -6.
Okay, then minus Q initial, it was? It was?
-2
Yebo.
times 10 to the power of -6.
Yes, you always have to target the negatively charged object or the one with more electrons first. Ne? That would be
Yes,
your
sir.
Q initial, because that's where electrons will flow from, because there's access, there's a lot of electrons. You agree?
Yes, sir.
Yes. All right. So what are we going to have? I don't know if you agree. You can use your calculator as well. You agree?
I'm checking, sir.
Okay.
Yes, sir.
All right. Perfect. Now from here, charge quantization. What does it say formula wise? Number of electrons is given by Q divided by Q, the Q of electrons. You remember this formula?
Yes, sir.
Yes, because we want to see how many numbers of electrons. If we know the amount of charge that we have and we divide it by the smallest charge, then we will know how many smallest charges are there. I think you understand.
Yes, sir.
So we will have 2.5 times 10 to the power of -6, all divided by how much? Divided by?
1.6 times 10 to the power of -19.
Okay, so what do we get there? What do we get? What do we get? You got
1.56
times.
times 10 to the power of. Okay.
Did you get that?
Yes, sir.
Okay, perfect. And the units?
Column, sir.
No. Remember, you're calculating the number of electrons. The number of electrons have no units. So
Mhm.
yes. So it's only charges that have column that have units, which are columns. This one was column, and the bottom one is column as well. The columns cancel, you see.
Yes, sir.
Okay, so you have successfully answered this question. Okay, now I'm gonna do a little bit of electricity. A little bit of electricity. Okay, before we start with the electricity questions, what is electrostatic? What is electrostatics? What is electrostatics, Kumis?
Study of charges at rest, sir.
Perfect. Okay, so what happens when the two spheres are brought into contact together and then separated? What happens? What happens to the electrons? Can you describe the process?
The electrons transferred from one object to another.
And then after separation, what happens to the charges after separation? Kumis, after separations, what happens to the charges?
I'm not sure, sir.
The end I cosmos. Okay, no problem. After separation, the two spheres will have the same amount of charge. You remember?
Can you repeat that, sir?
After separation, the two spheres will have the same charge. Do you agree?
Yes, sir.
And to calculate that charge, we know that the Q nu will be Q1 plus Q2 divided by 2. And what we get, which was 0.5, it is the charge on both spheres after separation. Because when you merge the two, the two becomes one and they share the same charge. When you separate the two, they still retain the same charge because at one instant they were one. You agree?
Yes, sir.
Okay. Now, when you bring them together after separation, what happens? When you try to bring them together, because they have the same charge, they will repel. You agree?
Yes, sir.
Yes. So that's the whole process of electrostatics. So all the questions will revolve around that, bringing two spheres together and separating them. So it's quite easy to get that one. Okay, so I'm gonna try to do an electricity question. Okay, before we move, I just want to do quick questions. What is current? What is current? Miss.
I think it's the flow of charge inside a conductor.
Perfect. Okay, what is resistance? What is a resistance?
flow of current in an electrical circuit, which results in energy convection.
You said is the flow of charge.
Flow of current, sir.
Unfortunately, it is not the flow. It is the opposition. It is the opposition of the current, or is the opposition of the flow of is the flow of what? The flow of charges. It's the opposition of the flow of charges. Okay. I'm gonna put up a question which we're gonna do together. And what is a potential difference? What is a potential difference?
Between the ends of a conductor is equal to the energy transferred from electrical to other forms of energy.
Okay. It is given by the work done between the 2 points of the conductor. Let me check the proper definition before I give you a wrong definition. The proper definition, the one that I wanted to learn. And what is the units of potential difference? What is the units of the potential difference?
I think it's V.
Yes, it's voltage. Okay, so I wanted to check which definition you use in your syllabus, because I was afraid that the definition that I was gonna give you was gonna be out of the syllabus. So work done is given by the potential difference is given by work done to shift or to move the charges through the conductor between 2 points in the conductor. It is the work done to shift the amount of charges. So V is given by W over Q. Okay, you get it.
Yes, sir.
But in using Ohm's law, how can you define the potential difference? Potential difference is given by
V is equals to I divided by R.
oh sorry. Khumbula man, ithi khumbula mos.
Yes, sir.
Yes. All right. Now name the physical quantity measured by voltage by a voltmeter. The physical quantities measured by a voltmeter. It is what? Potential difference. You agree?
Yes, sir.
Okay. Define the term resistance. What is the resistance? A resistance
The opposition of the flow of current in an electrical circuit.
Okay, flow of current in a conductor, ne?
Current.
In a
Current.
no, but is the opposition of the flow of charges, ne? Let's just say charges.
Yes, sir.
In a, remember the charges are moving inside a conductor. But you can also say opposition of current in a conductor. You agree?
Yes, sir.
Okay. Now, calculate the equivalent resistance of the resistors connected in parallel. There we go. Which formula should I use? Equivalent resistance of the parallel resistors. Remember from last week, I said you need to ensure that you eliminate all the parallel connections, right?
Yes, sir.
By finding an equivalent resistance. How do we find the equivalent resistance of two parallel resistors? We forgot.
1 over RT is equals to 1 over R1 plus 1 over R2.
Perfect. Then 1 over RT will be equals to, what do we have? It's going to be 1 over what? 1 over
20, 28. Is it 28 or 24? I didn't say proper. 24.
Yeah. 1 over 24 plus 1 over 8 will give us, what do we have? It will give us, you have a calculator, boss?
Yes, sir.
Okay, let's do it.
Okay. One over 6.
1 over 6 equals 1 over RT. Now, what is RT? RT is equal to what?
1 over 6.
Is equal to?
1 over 6.
But remember, 1 over 6 is actually one. It's 1 over RT. One over RT is equals to 1 over 6. You agree? The trick
Yes,
is
sir.
we are not calculating RT in this case. We are calculating 1 over RT. Ne?
Yes, sir.
So if you cross multiply, RT times 1 will give you RT. 6 times 1 will give you 6. You agree?
Yes, sir.
So I urge you next time, don't fall for that trick. It's 1 over RT. The answer that you get, if you want to get the proper answer, you must say 1 over whatever you have gotten. Then that will be the value of RT, not the value of 1 over RT. Are we together?
Yes, sir.
Okay. Now, what is the total resistance of the circuit? The total resistance of the circuit?
It's going to be R is equals to V times I.
It's gonna be
R is equals to V times I.
V over, is it V over I?
I said V times R. That's correct.
V times
V times I.
V times I. Okay. Is that R equals V times I?
Yes, sir.
Okay. Unfortunately, is that Ohm's law?
Yeah.
Remember, Ohm's law doesn't change. Ohm's law says V equals I times R. And I equals V over R. And R equals V over I. Remember that. Ne?
Yes, sir.
And remember, here they said the total resistance of the circuit. The total resistance of the circuit. The reason why I asked you to calculate the equivalent resistance, ne? It is because in order for you to calculate the total resistance, you need to have all the equivalent resistances and add them with all the resistors that are connected in series. Ne?
Yes, sir.
So we have a new resistor. Well, no, we have a new circuit which has 6 ohm resistance and 2 ohm resistance. Then 24 voltage. So now it's easy. The total resistance in series is what? Because that's what they're looking for. Tumisa, what is it? Our total
R1 plus R2.
that's it. So throughout your tests or exams, that's what you're going to be dealing with. You're going to be dealing with first step, resolve your parallel resistance. After resolving it, you get a new circuit which is in series. Ne?
Yes, sir.
And then to calculate the total amount of resistance, you have R1 plus R2, which will be 2 plus 6. You agree?
Yes, sir.
We have 8 ohms, total resistance. That's perfect. Okay. Now, when the switch is closed, a voltmeter connected across 2 ohm resistor measures 6 volts. Ne? Determine the potential difference across the parallel combination. When the switch is closed, they said the voltage across the 2 ohm resistor was 6V. They said determine the potential difference across the parallel combination. Now, how do we go about this one? Kumis. We will use the thing is, the aim of resolving circuits is to ensure that at the end we have the following. At the end, we must have V total is equals to I total divided by, no, it is actually I total times R total. This is Ohm's law. At the end, the aim of resolving circuits is to make sure that we have resolved for all this. We have all these vectors. Do we have the total V?
No, sir.
We don't have.
Oh. 24, sir.
24. Perfect. Okay. We have 20. V total is equals to 24. Then we are happy we got V total. Do we have I total? Do we have it?
No, sir.
No, we don't have. Do we have R total?
Yes, sir.
Perfect, which is 8. So can we find I total?
Yes, sir.
I total is equal to
R total divided by is V total divided by R total.
perfect. Okay, which will be, you agree?
Yes, sir.
Perfect. This will be 24 divided by
6, sir.
okay, 6. What is the units of I or the current? What is the units of current?
A, sir.
Which is amperes, right?
Yes, sir.
And the units of resistance?
Ohms.
Perfect. Okay. We have I total. We have V total and the total resistance. Now we know the flow. So given that we know the flow, it means it will be very easy for us to determine the potential difference. So that's the aim of resolving. If you are resolving a circuit, you are resolving so that you can find V total, I total, and R total. Are we in the same page?
Yes, sir.
Okay. Now the question says, determine the potential difference across the parallel combination. Okay. So what is the resistance? So how do we go about it? Yeah, I want your opinion. How can I calculate the potential difference across the parallel combination? The total current.
You already calculated.
No, actually, no, not the total current, the potential difference. Sorry, how do we calculate it?
V is equals to resistor times current.
Perfect. Okay, so we're gonna have what and what?
Eight ohms.
Okay. But remember they said the potential difference across the what? The parallel connection only. Who means you see? across the parallel connection, not of the total circuit, only on the parallel connection. What resistance do we have, or what is the equivalent resistance of the parallel connection? That's the first question.
6 ohms.
It was 6 ohms. So why are we using 8? But do you understand?
Yes, sir.
Times what is the current? What is the flow through the parallel connection?
6. Oh my God.
6 ohm. So this will give us 6 times 6.
36.
The units.
36 volts. 24.
Volts. Oh, there's something that I'm speaking here. Okay, let me see. Current is given by 24. Nah. 24 divided by 8. Ute 6 amperes. I think your calculator has a problem. Because your calculations are not making sense. It's not 6. Can you repeat 24 divided by 8? Let's see.
It's 3, sir.
Yeah, you see. Because there's no way the potential difference across the parallel connection is greater than the potential difference that is given by the battery. There's no way. Okay, so we're gonna have 6 times
3.
6 times 3, which will give us
18 volts.
18 volts. Okay. Okay. That is the potential difference across the parallel connection. Okay. Now, what is the potential difference across the 2 ohms? That one will be very simple.
See, it's
It will be the total minus what we have on the parallel section. So it will be 24 minus 18. You agree?
yes, sir.
Okay, but that was not asked. I was just saying. Now, the charge of 18 coulombs flow through a battery in 6 seconds. Define a coulomb of a charge. What is a coulomb of a charge?
I forgot, sir.
A coulomb of a charge. One coulomb is given by 1 coulomb. No. Let me just say 1 charge is given by 1.6 times 10 to the power of 19. I could just write that. That's 1 charge. Coulombs, you agree?
Yes, sir.
Charge quantization, same thing. Now use the data supplied in 1.5 and calculate the current in the 2 ohm resistance. Now, how do we calculate the current in the 2 ohm resistor? given the information we've been given. You can also, on the same definition, you can also express current in terms of a charge. Ne?
Yes, sir.
So you can say I equals Q over T, or you can even define it. You can say one charge, you can say current is the charge that passes a point per second or over a given time. We can say whatever, but this is the formula. Okay.
Yes, sir.
Okay, now they say calculate the current in the 2 ohm resistor. So how do we go about it? How do we calculate?
I is equals to Q divided by T.
Perfect. All right. Then we have how many coulombs? 18. You agree?
Yes, sir.
And the time?
3 seconds. Or 6.
6, yes. 6 seconds. What do we have?
Yeah, it's 18. It's 18, sir. The
18
coulombs. The Q says 18 coulombs.
18 coulombs.
But the Q say
Q is 18 coulombs. Okay. All right. So 18 divided by 6 will give us what? What, 3A?
3. Yes, it's 3. 3 amps.
3 amps. Okay. Now they said calculate the what? Calculate the current in the 2 ohm resistor. We do have the current. Do we have the potential difference?
Yes, sir.
It is what? The potential difference across the 2 ohm is what?
18 volts, sir.
It is 18 volts.
Yes, sir.
But remember that 18 was for the parallel, Kumis. For the parallel combination, I agree that if you come and measure with your voltmeter there, you will get 18 volts. So if you get 18 volts there, what are you going to get here? 24 minus 18. You agree?
Yes, sir.
Which will be 6 volts. So you have 6 volts. So I can see that we don't have time anymore. So can we have another class? Today is what? Today's Thursday.
Today's Wednesday, sir.
Today's Wednesday, yeah. So can we have another class tomorrow? We're just gonna continue. Sir. Yeah, I'm also gonna give you a homework, Nick.
Yes, sir.
Which you will answer and upload it on Google Classroom. Then I'm just gonna mark it and give you the feedback. So on the next lessons, which is on Tuesday, I'm gonna teach based on what you have answered.
Yes, sir.
All right. I'll see you on Thursday.
Sure, sir.
Sure.